Hello friends, welcome to my channel. Let's have a look at an easy problem, that is problem 2367, number of arithmetic triplets. In this video, we're going to share two methods for this problem. The first one is a brute force solution, and the second one is the standard set, abstract data structure, and check method. So this problem requires to return the number of unique arithmetic triplets. So in the problem, it first defines what's a desired arithmetic triplet in this problem. So a triplet IGK is an arithmetic triplet if the following conditions are met. First, so the three indices are distinct, and then the corresponding gaps are both equal to the given gap diff. So here are two examples. So in example 1, so the output is 2, and the indices, for example, this 1, 2, 4 forms a triplet, so with the required property. Similarly, in example 2, so the output is also 2. So here are the two triplets. So the constraints for this problem actually important for us. For example, the last one says that the nums is strictly increasing. So in particular, so the numbers or elements in the nums array are distinct. And the first constraint is that the length is bounded above by 200, so which is actually a small number. So if we compute 200 to the power 3, in other words, 200 cubed, so this is 8 times 10 to the power 6. So it's still doable if we use a brute force solution. So the greater than or equal to 3 is actually a consistency assumption because we need at least 3 distinct indices. So with that said, let's look at the methods. So as we mentioned, we're going to provide two formats of solutions. The first one is a brute force solution. So basically, we actually check if the gaps are the same and they equal the diff specified by the problem. And the second method is a standard set, abstract data structure, and check method. Actually, for this line of idea, we have practiced quite a number of problems, starting from the basic two-sum problems or two-sum problem. So here, the idea is the following. So for each element y in nums array, we check if this y is a middle element corresponding to a desired arithmetic triplet. So in other words, we check if both y minus diff and y plus diff are in the nums. So here is an extension. We are going to come back to this point after we write the code. So here is a walkthrough for example 1 according to the set and check method. So basically, we initialize our result, and then we can check so if a number can be a middle point for a corresponding arithmetic triplet. So we can see 1, right? So 1 minus 3 is not, so we continue. We see 4. So 4 minus 3 and 4 plus 3 are in the nums, so we are going to increment the result variable by 1. And then we look at 6. 6 minus 3 is not in nums, so we look at 7. So 7 minus 3 and 7 plus 3 are both in nums, so we increment the result variable by 1 again. So actually we can look at 10, or because it's the last element, it cannot be a middle element corresponding to a valid arithmetic triplet. Therefore, so the final result will be 2. So with that said, let's do our coding. So first, we're going to write the code using pure brute force. So this maybe we understand as that we practice some basic syntax. So here, let's first initialize the result, whose final state is what we want to return. And the n is the length of the nums array. And then we do the for loops. So for I in range m. Then for j in range, I'm going to write I plus 1 then to m. The reason is that we want to make sure the indices are distinct. Then for k in range g plus 1 to m. Then we're going to check the conditions for a valid arithmetic triplet. That is, if nums k minus nums I nums g equals nums g minus nums I and equals the diff given by the problem statement. And then if this is the case, we're going to increment the result by 1. And finally, we are going to return the state of the result. So that's about it for this pure brute force solution. So let's do a special case check. It passes the special case. Now let's look at the generic case. Yeah, it passes the generic case, but it's a little bit slow. So now let's look at the second solution. So the second solution, I'm first going to copy the function signature, and then put it here, and then I'll change this to be v1. Then what we want to do for this one, so let's make some annotation. So this is set ADT and check. So for this, we're going to follow the idea for method 2. So first, I'm going to initialize a result, and then actually we can transform this nums to a set. So here, this is not absolutely necessary, but I would like to emphasize we are using set and check method. And then we're going to iterate for y in nums, and then we want to check if y minus diff in the auxiliary set and y plus diff is in the auxiliary set. If this is the case, we're going to increment the result by 1, and afterwards we're going to return the result. So that's the set, abstract data structure, and check method. So let's do a special case check. Yeah, it passes the special case. Now let's do a generic case check. So yeah, it passes the generic cases. So in this specific problem, actually we do not need to specifically introduce this auxiliary set. So we can do things like this. So let me copy this second solution, and then I'm going to change this to v2. And then for this, I'm going to delete this line, and then we're going to use here nums, here nums. And then let's do a check. So it also passes all the cases, but this way, the second way, is a standard way of using the set abstract data structure and check. So now let's come back to the problem statement. So in this problem statement, we are required to return the number of unique arithmetic triplets. So here, actually, the diff is given. So if we extend the problem a little bit without giving the diff, then we ask how many different arithmetic progression. So that's actually another problem. Also, we can relax the assumption. For example, here, nums is strictly increasing. How about we do not require it's strictly increasing? So, for example, in example 1, so this element 1 can appear, say, 7 times. Then in this case, if we want to do the counting, so here is the extension. So we can actually update the set abstract data structure to a dictionary data abstract data structure, and then we count the number and the corresponding frequencies. Then we use the unique numbers to help decide arithmetic triplets elements, and then we use the frequency to do the final counting. So with that covered, I guess that's about it for this video and for this problem. Thank you very much.